The goal for the day is to try to figure out how to do tangent lines. It's almost going to feel like we've already done this before because we have. We talked about tangent lines when we did derivatives a long way, but tangent lines just got much easier because we have shortcuts. So that's going to be our goal for the day. Before we do that, I have some AP problems up here to practice, some AP practice problems. The first one was pretty interesting, I thought. So it says, use the graph at the right to answer the questions. Find h prime of 1. Okay. Well, what is h prime of 1? What is h prime? First of all. What is a chain rule? F prime of g of x. That's g prime of x. And I'm going to plug in 1. So the first thing I need to find is g of 1 and g prime of 1. And it's hard to tell, but this graph here is labeled g. So if I go to g of 1, I get 4. So this is the same as f prime of 4. G prime of 1. How would I find g prime from a graph? If that's g, what's g prime?
0.
What is it, though? What is g prime? What does it mean? It is a derivative. Slope. Luckily, this is just a line. Can I find the slope of a line? So it's rise. It looks like 2 over run. 1, 2, 3, 4. So negative 1/2 since I'm going to the left.
That's 2.
Say that again.
If you start
Just go up 1. Just go up 1 from where you started.
Oh, yeah, okay, that works. 1 over 2, which is either way, negative 1/2. Okay, any questions so far? And then f prime of 4. Can I find f prime of 4? It's the slope, negative 1. So positive 1/2. It's negative 1 times positive 1/2. Negative 1 times negative 4 is positive.
So on the derivatives on that, you just
Yep. For a graph, to find the derivative from a graph of f or g, you find the slope.
So if it was at 3, that's the prime of 3, then it would be undefined or whatever.
That's right. Which is probably a straight repeat.
How do you know when the slope is positive?
If it's like this, it's negative. Like this, it's positive. Now, when you do rise over run, you can tell that by if you ever go down or left, those are negative directions. So I would rise 1, left 2, and so that left direction is where the negative came from. But in general, anytime the line is going down to the right, it's negative. S prime is g prime of f of x times f prime of x. So I want g prime of f of 5 times f prime of 5. F prime of 5, I can find out. It's still negative 1, isn't it? Because it's still on that same line that I already found the slope of. F of 5 is 2, 3, 4, 5, 6. So I have g prime of 6. I knew I had one on there somewhere. G prime of 6. What's the slope at 6? Undefined. It's a sharp corner. So the derivative does not exist at a sharp corner. So this whole thing does not exist because g prime of 6 does not exist. So that was an interesting question. Number 2 is a real AP multiple choice problem. I hope that's encouraging to you. It does require some properties of logarithms. You could work it as it sits. It would work. It's a chain rule problem if you leave it as it sits. I would not leave it as it sits. What does natural log in E do? Cancel. Isn't that just 2x? And what is the derivative of 2x? Real AP problem. So they just wanted to know, do you know properties of logarithms? Can you take a basic derivative? Or you could have done a chain rule. But how would interval 1 to 10, if f of 2 is negative 5, and f of 5 is 5, and f of 9 is negative 5, which of the following must be true? So I'm just going to plot that real quick. So we're silly. F of 2 is negative 5. F of 5 is 5. And f of 9 is negative 5. F has at least 2 zeros. I would agree. How do you know that though? If the function is differentiable, what does that also mean that it is? It's continuous. And so it has to cross the x-axis twice. So I agree, 1 is true. It has to have at least 2 zeros. The graph has at least 1 horizontal tangent. What's that mean? Well, it does say it's differentiable, right? So no sharp corners or anything, right? So that means somehow I get from here down here smoothly. Wouldn't there have to be a time that I have a horizontal tangent where I turn around? Now, was it differentiable? That wouldn't be true because I could have a point and I could have no horizontal tangent, but the way it's worded, I have to have it. First, sum c between 2 and 5, f of c equals 3. Would you agree? Yes, that's another intermediate value theorem. F of c equaling 3, well 3 is right here. Am I going to have to cross that y value somewhere between 2 and 5? Intermediate value theorem. So all 3 are true. That second one there is a theorem you don't know yet. But it makes perfect sense. We'll learn that theorem later. Okay, we are not learning that theorem today. Oh, awesome. Today we're going to focus on tangent lines and normal lines. And so before we go on, I want to kind of point out what we know. There are 2 things that you know at this point. You know your stuff from Algebra 1, and you know your stuff from Calculus. And the AP exam will test both of them. So we're going to kind of talk about what we know. In algebra, you learn how to find the slope between 2 points, or the average slope, or the average rate of change, or the average velocity. We did learn this word in here, slope of the secant line. And we use y2 minus y1 equals x, or divided by x2 minus x1 for the slope. That's what you knew already. So if they ever ask any of those questions, don't do calculus. Do algebra. But then we learned the derivative, and the derivative gives us the slope at a single point, or the instantaneous slope, or the instantaneous rate of change, or the instantaneous velocity, or the slope of the tangent line. That does involve a limit. Because the derivative allows us to find the slope at one point, we can find the equation of a tangent line. And that's what we're going to focus on today, is how to find the equation of a tangent line. I've actually shown you this already, so this shouldn't feel real new, but we've got to actually sit and do it because it is something that's tested quite heavily on the AP. We are always going to use point-slope form when we're finding an equation of a tangent line. And I showed you this a couple days ago, but if you didn't write it down, this is point-slope form. We will be using that to find tangent lines. The wonderful thing about the AP exam is you don't have to rewrite it. You can leave it in point-slope form. Unless the multiple choice problem makes you, for some reason, we're going to stop at that. A lot of times, even the multiple choice don't write in point-slope form. Occasionally, they'll make you rearrange it. Well, forgive them. So, example, find the equation of the line tangent to f of x equals x squared minus 5x plus 3 at x equals 3. Well, what are the things that I need for a tangent line? Or any line in general? What are the two things I need for a tangent line? Or for a line? To write the equation of a line, I need a slope, and I need a point. Or y-intercept, if we have it, we'll take it. But I don't have to have a y-intercept, any point will do. So, I'm going to find a slope and a point, and I'm going to use that to write the equation of the tangent line. Well, it tells me the x value of my point. If I have an x value, how do I find a y value? You plug it in, right? Put it into the equation. 3 squared is 9, 9 minus 15 is negative 6. Plus 3 is negative 3. I should check my math. Should mess up. Any questions about that so far? And what about slope of a tangent line? What is the slope of a tangent line? It's a new definition to us. The derivative. So I need the derivative at 3. So first I'm going to find f prime of x, which is 2x minus 5. And then I'm going to find f prime at 3. Never write a tangent line without a number for your slope. We don't want equations in our tangent line. We want numbers. We're just writing a line. And so f prime of 3 is 1. So my equation of my tangent line is y plus 3 equals m times x minus 3. Where did I get that y minus stuff? Point slope form. So y minus negative 3, which is plus 3, equals slope times x minus 3.
So change the y1 to y2.
Because it's minus a negative.
But how come it didn't go to y with the negative 3? How come it go to the y?
That's a specific point. And so in my equation here, my specific point is the x1 and the y1. So if you wanted to label this x1, y1 in your notes, you can. But it's an x and a y. Another line that's important in physics is called the normal line. Is anyone in physics? You are. You might hear about normal lines when you get to vectors. They are opposite, opposite.
Definitely part of the eruption. I need city farming students in the high school office. Connor Beaker, Caitlin Joyce, Justin Jones, Jameson Griffin, Cheyenne Fortin, Brian Zerba, Cooper Van Cooten, Bailey Miller, and Lindsay Thomas in the high school office. Thank you.
Their tangent lines give you the slope at the points, or give you the velocity and things like that. The normal line has some applications in physics. For our purposes, we won't ever get to the applications of it, but we will be asked to find normal lines a lot. They are simply lines that are perpendicular to the tangent line. That's all you have to do is use our Alpha 1 skills to find a perpendicular line. So to find a normal line, this is the same equation, isn't it? At 3. Well, I already know the point at 3 is 3, negative 3. But the slope of the normal line is the perpendicular slope to my tangent line. So how do you find perpendicular slopes? Opposite, reciprocal, right? Opposite and reciprocal. You change the sign and you flip it. So what happens when you flip one and change the sign? The beauty of rewriting or using point slope form is I don't have to find b again. I don't have to find the y-intercept again. I just write the exact same thing I wrote last time, except with a different slope. So they ask you to find tangent line, normal line, it's really easy. You just do the opposite of vertical slope. I have 3 questions down here at the bottom. I'm going to find the slope of the secant line between 1 and 5 of the function there. I'm going to find the equation of the tangent line at 3, and I want to find the equation of the normal line at 3. So see if you can do it. What class do you want to pretend you're in when it asks you to find the slope of the secant line? Algebra 1. Maybe it's a little harder function than you would have in Algebra 1. Other than that, though. How are we going to find the slope of the secant line? What do we need? 2 points. And I already have the 2x values, right? So I could even, essentially I'm doing f of 5 minus f of 1 over 5 minus 1. This is another way to write algebra 1 slope, right? F of b minus f of a over b minus a. Or y2 minus y1 over x2 minus x1. So I need to know the y values at 5 and 1 to find the slope. I need y1 and y2. So I'm going to plug in 5. 5 minus 2 is 3 fourths. No, 3 sixths. So half. And negative 1 over 2. Negative 1 half. What is 1 half minus negative 1 half? 1. 1/4. So the slope of my secant line is 1/4. If I did want to write a secant line, I could. I have a slope and I have a point. I could do that. It didn't ask me to. So side note, didn't ask this question. But if I wanted to, it would be something like y minus a half equals a fourth times x minus 5. I don't know where I got the 5 and the 1 half from. The x value and the y value. I could have picked the other x and y value if I wanted to. I could use 1 and then. So that's how you, if you were to write an equation of secant line. It's only asked for the slope. The next one does ask for the equation of the tangent line at 3. So I can find the y value at 3 pretty easily. 3 minus 2 is 1 over 4. That's the y value at 3. What else do I need besides x and y? I need a slope, and how am I going to find a slope? Derivative, and how do you do the derivative of something that looks like that? Quotient rule. Low, d high. Said it right, didn't I? I need an x, a y, and an m to find a 3. Plug in 3, and that gave me the y value. So this is f of, I could say it that way so you know exactly what I got it. This is f of 3. The y value. Low, d high minus high, d low, all over low squared. Now you can simplify it if you want to, but what am I going to do to it? I'm going to plug in 3. So you can simplify it first and then plug in 3, or you can just plug in 3 now. It's up to you. F prime of 3 is 4 minus 1, so 3 on top, over 4 squared, which is 16. Okay, with where I'm getting all that with that. So my equation of my tangent line is y minus a fourth equals the slope of 3/16 times x minus the x value. So you need 3 things, really 2 things, but we'll go 3. You need an x, you need a y, and you need a slope. And you've got your equation. negative and flip. So the normal line, once you've done the tangent line, it's very easy. Y minus 4 equals negative 16 thirds. So what's the only thing I changed in that line to get normal versus tangent? Just did the opposite reciprocal slope. I just found the normal line. Everything else would be the same. Now, if they try to trick you and change the 3 to a different point, you'd have to do a little bit more work. But not just slope negative. Alright. Tangent line approximation, or what's called a linear approximation. If you are close to a point on a function, the function and the tangent line are almost identical. And when I say close, I mean really close, not points away, but decimal values away. So if you wanted to approximate the value of 0.1 on the graph, but you couldn't plug 0.1 in, and I know you're going, but I could plug 0.1 in. What's sine of 0.1? No, but I do know sine of 0, and I know the slope of sine at 0. And so I could write an equation of a tangent line, and then I can plug 0.1 into a line pretty easily. And so tangent line approximations are a way to approximate the value close to a point that you know. This does have a lot of applications later when in mathematics and functions you really have to. So we can approximate with a tangent line. So it says use the tangent line at x equals 2 to approximate f of 2.1. Well, first I've got to find a tangent line. What do I need to find a tangent line? Slope, the x, the y. I already have the x, the 2, so let's find a tangent line at 2. The slope would be 1x squared minus 2. Everyone agree? Is 2.1. So I'm going to find f prime of 2. Remember, I'm finding the tangent line at 2. I will then use that to find the bracket. 2 squared, which is 4, minus 2 is 2. So I have my slope. What else do I need? A y value, so I'm going to find f of 2. 8 thirds minus 4 plus 1. So that's negative 3, which would be negative 9 thirds. You could do a little more work to get that if you need to. Is that right? I'll check my work. Okay, so my equation of my tangent line is y plus 1/3 equals 2 times x minus 2. That's my tangent line. I want to approximate f of 2. So I'm going to put 2.1. I'm going to put 2.1 right here where the x is, and that's my first x. Just plug in 2.1 for an x. Now, why is that useful? Well, 2.1 minus 2, can I do that by hand? 0.1, right? Let's do it. Y plus 1/3. So that's 0.1. 0.1 times 2 is 0.2. And then 0.2 minus 1/3. I don't care if you use a calculator on this. But you link that to 2/10 is right as 2/10 or 1/5. So you could get a common denominator. It can be done by hand. Let's see, it's fifth, so that would be 3/15 times 5/15, negative 2/15. Okay, question. Question. Why did I put approximate there? That's actually a fraction.
Because it says the tangent line approximate.
Right, the tangent line does not give me f of 1 or 2.1, but it gives me something close to it. Just for fun, in your calculator, type 2.1 into that function. Type 2.1 into that. So 1/3, 2.1 cubed minus 2 times 2.1 plus 1. Do you agree you really want a calculator to type that in? To do the cube of 2.1? But the other one, even though it did have some tedious fractions in it, was doable by hand. What do we get? Let me type that in. Very close? You don't know.
Well, I trust your approximation.
I mean, it's not perfect. It is.
I'm thinking, you know, like everyone else goes through calculation.
So what do you get?
I mean, it's 2.1 and then an x, right? Plug in the 2. If that's what it's really good.
It's negative 0.113.
There you go.
And negative 2/15 is negative 0.13. So, not too terrible, right? For an approximation, definitely something we could do by hand. So you can see applications of this later in calculus.
Do you think if it was like 2.3, it would have been off more?
Yes, the farther away from the point, the worse the approximation will be. Now there is a thing, we won't do it in Cal 1 instead of Cal 2, where you can do repeated tangent line approximations. So you can get closer and closer. And then you can find an error and analyze what your errors on the calc. I'll get you to speech type this year. Okay, find all points on the curve of x squared minus 2x plus 6 where the tangent line is horizontal. When would the tangent line be horizontal? At a maximum or minimum, so that's important. And then how could you find that? You could graph it, but I don't want to. I want to do it with no graph. Which sounds hard. What do you think? You could. I don't want to do that either. That sounds tedious. What is the slope of a horizontal line? And is the derivative the slope? That's pretty easy to do. Two over the other two. So x is 1. That is where the tangent line is horizontal. It does say find the points on the curve. Well, how would I find the points on the curve? I'm almost there. I'm halfway.
You have x, you plug that in.
So I have x, plug it in and get the y value. 1 squared is 1 minus 2 is 1 plus 6 is 5. So than finding the maximum or minimum in your calculator. That really, once you get good at it, that didn't take long. Suppose, and this is an AP style question that an AP would ask. Suppose f of 2 is 7, f prime of 2 is 4, f of 0 is -2, and f prime of 0 is 2. Use a local linear approximation to estimate 2.1. Anytime you hear the words local linear approximation, what should you think? Anytime you hear local linear approximation, it's saying use a local line or a tangent line. Local linear approximation. So it's saying approximate this using a line. And so to do that, now the reason they say local is because it has to be close to. Speaking of, since we're finding f of 2.1, which tangent line should we use? At 2, right? Does everyone agree we should find the tangent line at 2? Tangent line at 0 would be completely not useful. And so you see the distractor, this AP problem threw it. It threw in a 0 as a distractor. But I want to write the equation of the tangent line. What are the 3 things I need? X, y, and m. At 2, do I have the y value? What is it? 7. Do I have the m? No. 4. Do I have the x? So it gave me everything I needed to write the tangent line. So to approximate the y value at 2.1, I make it too cold in here. 0.1 times 4 is 0.4. Okay, I got that. I am going to make one more statement, and I want you to always do this also. I'm going to say f of 2.1 is approximately 7.4. Make sure you don't say it equals 7.4 because remember it is an approximation. Questions about that?
Can we do like a sine or cosine?
I have one up here. We could. Let's do this one first because it's an interesting question. The rest are just more tangent line problems. How do y'all feel about tangent lines? If it were a trig function, and I can take one up in a second, I can do one. You just would plug in whatever values. You do the derivative, so if it's sine, you do the derivative, which would be cosine. If you're finding the tangent line at 0, you do y minus sine of 0 equals cosine of 0 times x minus 0. You just plug in those values. It wouldn't be any different. I'll have to see kind of what your question is. When I'm finished, I can go do something that's trig related. Match the graph of a function with its derivative. Well, we've learned some things today. Kelsey said earlier, I have horizontal tangents at maximums and minimums. So if the tangent line is horizontal, the derivative is 0, right? So let's look at A, B, C, and D. Those are the original functions. Would you agree that where those equal 0, my derivative should cross the x-axis? So this one, I have a horizontal tangent here and here. So I should have something that crosses the x-axis 2 times. Which one does that? In those locations? 4. Does everyone know? So the derivative graph of A would look like number 4. The horizontal tangents fall in the right place. We'll do a lot of practice with this next chapter, so this is kind of our first look at it. B, where is there a horizontal tangent on B? At 0, and it looks like that's the only one. Do I agree? So the x-axis at those places. And then by default, this must be 1. Does it make sense that it's 1? Got a strange graph. Its derivative would probably be strange. Makes sense. Trial and error, we did it. Now, let me show you some other things we could have looked at that we didn't have to. Slope. Would you agree that slope of this is negative, then positive, then negative? Negative, positive, negative.
No.
This function is negative down here.
Why though? 'Cause it's going
Below the x-axis. It's just below the x-axis, so it has negative numbers. And then it's positive up here. And then negative down here. So it seems to look reasonable. Again, look more at that later. I'm not going to do that one. Are y'all okay with that? Yes. Horizontal tangent. We do that. Find an equation of a line that is tangent. This one's a tough one. I don't think you have any of your homework like this, but we'll do it. Find an equation of a line that is tangent to the graph of f and parallel to that line. Well, first of all, if we're parallel to this line, I want to know what that means. Do you agree this is the line y equals 3x minus 4? So my tangent line has a slope of 3. Everyone agree? The slope of the tangent line is 3x squared. And I want that to be 3. So we're kind of going backwards. We know the slope, want to find where that happens at. What would x be to get a tangent line of 3? 1 or negative? Everyone agree? And then could I find the y values of those two things? So I actually have 2 answers on this. Y minus 1 equals 3 times x minus 1. And y plus 1 equals 3 times x plus 1. So those are the 2 tangent lines that are parallel to that one. So there are 2 of them on this particular problem.
So right side was the equation of the.
The right hand was the equation of some random line that my tangent lines were parallel to. And it wanted to find the tangent lines that are parallel. And as long as they had a slope of 3, that's all that required. And so we just had to find the points that happened. So that was kind of a problem. Okay, your homework has the book page written at the top. Notice it is on there. I even gave you blanks. Write the answers on the book page so I can have a place to put them. And so it's part of the worksheet. Go ahead and get started. Have time to do a few problems. I think you'll find it's a nice break from table. Am I right? Maybe. So try a few problems if you have any questions. If you have any more questions, ask those. You'd rather